Hello everyone, this is G. Karthik Reddy working as Associate Professor in the Department of ECE, MLR Institute of Technology, Hyderabad. And the topic is Bayes theorem. What is Bayes theorem? We are going to discuss what is Bayes theorem, what is a formula associated with the Bayes theorem, understanding the theorem with an example, solution using Bayes theorem, application of total Bayes theorem, advantages and limitations. Okay, Bayes theorem. What is Bayes theorem? Okay, Bayes theorem, the scientist name Thomas Bayes on 18th century, he introduced the concept of Bayes theorem. Bayes theorem. Next what he has done this is, he described the probability of an event based on prior knowledge of the conditions related to the event. Bayes theorem is applicable only with the prior knowledge of the events. Okay, event is known before, then only we can apply the Bayes theorem concept. Okay, priori concepts only applicable in case of Bayes theorem. Posterior concepts are not applicable in the Bayes theorem. Those are applicable for conditional probability theorem. Next, for updating the probability based on new evidence. Bayes theorem. What is the formula of Bayes theorem? P of A by Bi. Okay, general formula is P of A by Bi is equal to P of Bi by A into P of A by P of Bi. Okay, this is a basic definition of Bayes theorem. Okay, this is the basic formula of the Bayes theorem. P of A by B, you know that posterior probability. Posterior means after. Means probability of this posterior after the during the probability, whenever they are giving the question as probability, for initially we don't know the event, that is a posterior probability. Probability of event A given event B, means here event B is given, event A we don't know it, that is a posterior probability. Next, P of B by A is the likelihood, probability of event B given event A. Okay, this one is already occurring. Next, prior probability. P of A is already defined. Before applying the probability, we know the event. That is a prior probability, initial probability of event A. Next, marginal probability. Marginal probability is also called as total probability theorem. What is total probability theorem? Tells that P of B or Bi is equal to P of A by, what is that? Bi by, okay, for example, if you are giving P of A by Bi, okay, from the concept of total probability theorem, we can apply the P of B. B of B you can apply from total probability theorem. Now next, understanding the Bayes theorem with an example. You have to understand. Okay, we are using for medical diagnostics. For example, if you are using the medical diagnostic scenario, a patient tests positive for a rare disease. Okay, same the concept which you are using for total probability theorem, same thing is applicable, but here in the total probability theorem, if you are having sample space, if you are having some for B1, B2, B3, B4, B5, likewise you are having B1 to B5, this defines the sample space, and B1 intersection B2 is a null set because there is no intersection between B1 and B2. When there is a common element between all these events, we are defining that as A. Now, P of A intersection B1 union P of A intersection B2, so on. You are going to get that as P of S. Now here, probability of having the disease, for example, if you are considering, that is 1%. Okay, probability of having the disease, that is a common factor. Next, probability of positive test you may have positive test or negative test. In the Bayes theorem, we are taking only the particular part. In that total probability theorem, we are taking for all the cases. Positive test, that is I am considering positive test is the, what is that? Positive test given the disease. Given the disease will be always in the denominator. The event which is known is always placed in the denominator. And the positive test P of T by D is 99%. Okay, just assumption only. Probability of positive test without the disease. Without the disease, then what you are having? 5%. First, we are taking with some example. Next, what is the probability that event actually has the disease? Event actually have the disease. Probability that event patient actually has the disease given a positive test result. Given positive test result. That is depending upon this, because here we know the prior. Okay, this is why, that is why this is case called prior events. Okay, now here you are having the P of D. D is what we already discussed, the probability of having the disease with respect to the test is positive test result. Positive test result. Use the same formula which we have discussed. Okay, use the same formula here. Here what he has discussed, P of D by T, which is equal to P of T by D into P of D by what you are going to get. Okay, here we are going to get P of T. Okay, this is the one we have to get. We are calculating that part only here. In the same thing, we are calculating this. P of D by T is equal to P of T by D into P of D by P of T. Okay, this is a calculation. This is a formula. You have to know it. Okay, first initially you have to define the events. Okay, what is the disease one and what is the test of positive. Okay, positive. Next, calculation of P of T. P of T is calculated by using total probability theorem. Total probability theorem, we can calculate the P of T. P of T is equal to P of T by D into P of D plus P of T by, which is not having the disease, into P of D dash. Find the probability and interest. You know the values. In the previous one, we have discussed the given values. Find probability of a positive test given the disease. Probability of positive test without the disease. You have given the values. Just you have to substitute those values. Substitute those values. P of T by D is what? 0.99 into P of D. P of D is how much? 0.01 plus P of T by D dash is 0.05 into, then what is the remaining portion? 0.099. You multiply this one, you will get the resultant value that represents the, what is the question? It is given that patient actually that the disease given a positive test result. Positive test result, you will get the solution of that. Next, what are the applications? Just now we discussed the medical diagnostics. Okay, updating the probability of a disease based on new test results. That is called, in the clearly we mentioned that new evidence, based on the new evidence. Next, spam filtering. Okay, spam filtering we are using for mail accounts, email accounts, calculating the likelihood of an email being spam based on the words present. Based on the words present, we are filtering that. In the machine learning also we are using for predictive models. Next, in the decision making, risk assessment and management in finance and insurance, we are using this concept. Most of the total probability theorem concepts are applicable for Bayes theorem, but here we are taking for new test results or new evidence concept, and which the event is known prior one. Okay, these things you have to be remember. Next, what are the misconceptions and challenges? Okay, what are the misconceptions of challenges of Bayes theorem? Okay, misinterpreting of prior and likelihood. Okay, you have to know that whether it is a prior event or likelihood one or not, we have to identify it. Okay, then only we can use the Bayes theorem concept. Confusing the conditional probability with marginal probability. Conditional probability we are using for posterior one. Okay, posterior one. Okay, the event one is, okay, one given event is known with unknown event, and marginal probability is the total probability one which we are calculating for common for all the one events. Next, importance for accurate prior data for reliable results. Okay, prior data, for accurate prior data we are using the concept of Bayes theorem. We are using the concept of Bayes theorem. And what are the advantages and limitations of Bayes theorem? Provides a systematic way to update the beliefs with new evidence. Okay, useful in situation with limited data. Whenever you are having only limited amount of data, you can use the concept of Bayes theorem. What are the limitations? Okay, compulsory we required prior information. Without prior information, we can't applicable for Bayes theorem. Computationally intensive for large data sets. Okay, for large data sets, it is more complex. That is why it is used for limited data applications. Thank you.